Good morning, dear students. Today we are going to discuss about one of the unicast routing protocol. So that we call it as a RIP protocol. So the RIP protocol is nothing but it is a routing information protocol. So this routing information protocol we are going to use in the case of internet network, where the data has to be forwarded from one network to another network. Okay, and we discussed that a single routing protocol is not possible for us to do the forwarding the packet in the case of internet. Why? Because of the scalability and the administrative issues. So therefore we should have a multiple routing protocol, and this multiple routing protocol will enable us to forward the packet successfully from one domain or from one network to another network. So that is a routing information protocol is also based upon the distance vector algorithm only. But in the distance vector algorithm protocol, whatever we have discussed, so it is mainly related to the intra network. So till now whatever we discussed distance vector routing algorithm, it mainly related to the intra network, whereas this routing information protocol, it is a inter network. So means what? If you want to forward your packet from one network to another network, then we are going to use this routing information protocol. And this routing information protocol, it was started, just wait a minute. This routing information protocol, it was started with as part of Xerox network system, and then it was built upon the Berkeley software distribution based upon the Unix platform. And when you want to forward the packet, as we discussed in the distance vector routing algorithm, we are going to count the distance between the nodes from the transmitter's node to the neighboring nodes. So means what? When we want to forward the packet, before forwarding the packet, we will estimate what is the distance, that is the minimum distance is there for me to reach from source to destination. So based upon the distances, that is the minimum distances, we are going to route the packet. So similarly, the same concept we are going to use in the routing information protocol. So here we use a half count. So this half count, basically it is nothing but the number of intermediate nodes which are present in order to do the data transmission from a source to destination. So this half count is nothing but is the same implementation what we have used in the distance vector algorithm. So now what we are going to do is, so the first, the AS what we have used. Okay, the AS has to communicate from one AS to another AS. So therefore, it is necessary for us to know the routing information of one AS to the subsequent AS, not the corresponding node. So the autonomous system, whatever we have discussed in the internet protocol or the internet architecture, so the AS will forward the routing table of one AS to the another AS. So based upon this routing information, or based upon the cost of estimation from one AS reaching to the another AS reaching, so based upon that we can able to forward the packet. And in the case of routing information protocol, so the maximum half count of what this routing information protocol works is 15. Maximum it works on the half count of 15. So if you need a more than 15 half count to reach from source to destination, then routing information protocol does not suit for data transmission. So based upon the feasibility and based upon the efficiency of the data transmission rate, this routing information protocol has been constrained. So the half count is maximum to reach a 15 values only. So this is how you are going to calculate the half count in a RIP protocol. So now you can see here in the given protocol, so we have 4 ASs there, that is the network from 1, network 2, network 3 and network 4, and the data has to be transmitted from the network 1 to network 4. So now what it does is, the source will get the information about the network 2, and the network 2 will get the information about the network 3, and the network 3 will get the information about the network 4. So when you want to forward your packet or when you want to forward the routing table which is associated to the network, not for the individual table, we will be transmitting. And one more important thing you need to assume is that, or one more important thing you need to understand is that, here we are going to forward the routing table. It is in a different manner. So still now what we used to do is we need to forward the routing table, the corresponding node to the corresponding distance vector we need to found it. But in the RIP protocol we will be using the routing table in a different manner. So how you are going to use the routing table in a different manner? Let us have a look on this. So now you can see here, this is the routing table which has been forwarded from router 1 to router, that is from the N1 to router 1, and the forward table of the routing 2 it has been displayed. The forwarding table, that is the routing table of R3 has been displayed. So if you carefully observe this, the routing table, this routing table in previous case you had only two columns. So what you had only two columns? So you had the corresponding node and you have a distance that node to reach from my particular node to the corresponding neighboring node. But here you have a three columns. So what are those three columns will correspond? The first column will correspond to the destination node. The first column will corresponding to the destination node. That means that the destination network is a destination network that has to the forward. The packet has to be forwarded. The second one is what is the next router to transmit the data to the destination node. So what is the next router that I need to transfer the packet? So that is will give you in the information will give you in the second column, and the third column will give you so how many hop count is required to reach the next router will be given in the third column. So that we call it the hop, the cost in hop value, that we call it as a cost in hop value. And when we are forwarding the data, that is from one router to another router, so this table will be transmitted from one network to another network. Okay, so by the use of the destination network and the next router, the subsequent router where the packet has to be transmitted, definitely we will be able to get the information. So in which direction the data has to be forwarded. You can ask me, then what is the use of this cost in hop count, sir? Why we need to forward this information from one routing table or from one router to another router? So why it is required is, if there is any updation is required in the network means, then it is necessary for us to know this hop count. So in order to update your network, before we are using this hop count, that is a cost in a count value before we forward the packet. And one more important thing what you need to see is that here we are forwarding the data not only within the network, we are forwarding the data from one network to another network. When I want to forward the data, I will not forward the individual forward routing table. Instead of that, I will be forwarding the routing table which is corresponding to the network. So the autonomous system which will receive this information, so based upon the autonomous system and based upon this routing table, the next router will have a decision on how I should forward the data so that it will reach to the destination. So this is how you will be using this forwarding table. We will be using these three information. One is a destination network, one more is the next router where I should transmit the data, and the next one is the cost of reaching the one network to another network. So we told you the cost is, it depends upon the type of network what we are using. The cost may be in terms of distance, that is the cost may be in terms of the energy level of the nodes, or the cost may be in terms of the minimum shortest path from source to destination. So how you define your network parameters, so based upon that we will represent the cost value. So in this case the cost value is the number of hop count or the number of intermediate node which are going to travels from source to destination. So based upon that we will assign a the next one is how you do this implementation, then how your routing information protocol will be implemented. So this routing information protocol we are going to implement through the use of user datagram protocol, and this user datagram protocol will works on the, or it uses a port number of 520 in the network in order to do the data transmission. Okay, And why we are using this RIP for the UDP datagram protocol is, so since the RIP has to work in a circuit switching network, so if you want to work it in a circuit switching network means there is no dedicated path will be established. So therefore we go for a user datagram protocol. So since user datagram protocol, it is a connection level protocol which will enable us to do the data transmission. So therefore we will be using this UDP protocol in order to transfer or in order to implement the information routing protocol. And one more thing you need to know is that this information routing protocol, actually it is an application layer protocol. This information routing protocol, it is actually application layer protocol, but the corresponding the process or the forwarding the packet, it will be based upon the UDP protocol. So since the UDP protocol is associated in the transport layer protocol, so therefore the forwarding of the data from source to destination will be done in the transportation layer and also in the network layer, because this RIP protocol is also in provision with the IP protocol, that is IP datagram. So therefore the forwarding of the data along with this UDP will be done in the network layer, whereas the implementation of this RIP protocol will take place in the application layer only. And whatever the information which you are going to receive in the RIP protocol, so that will be encapsulated through the use of the UDP datagram, and which in turn encapsulated by the use of a IP datagram. So we know that what you mean by encapsulation is decapsulation. Encapsulation is nothing but for the data we are going to attach the header and tailor, means we are going to bind the data with a starting address and a stopping address, that is a source and destination, and this data will go into the lower layer, and again in the lower layer this we call it as a data. The data which we have received from the upper layer will be taken as a data, and for that data we are going to attach the source and the destinations. So that process we call it as an encapsulation method. So in RIP implementation, whatever the data or information we are going to get from the application layer, that will be encapsulated through the use of UDP protocol, and that in turn encapsulated with the IP protocol in order to forwarding the packet. So this is how you are going to do the implementation of your RIP protocol. So the next one is, so this RIP has two important versions of implementation. So the first implementation we call it as a RIP1 implementation, and also one more we call it as a RIP2 implementation. Among this RIP1 and RIP2 implementation, the second one is giving more priority. Why? Because of the scalability and feasibility of implementation over the IP datagram. So therefore we go in detail the analysis of the RIP2 version protocol, and this RIP2 version protocol, it is compatible with the a backbone network. So in the internet protocol we can able to see that the core network has been connected to the backbone network. From the backbone network it was connected to the internet service provider, and from the internet service provider it was connected to the end customer user. So this RIP protocol will facilitate the use of the backbone network. In turn, in connection to the backbone network, this RIP2 protocol will play an important role. And in the case of this RIP protocol, so the information will be sent in the form of RIP messages. Okay, so it is similar to how you transfer the data from source to destination. So like that, RIP messages will be transmitted from the client to server basis. So it uses to exchange of messages. It uses or it needs to exchange of messages which are defined in a particular format. So this RIP implementation too, it will exchange the information and which has to be defined in a particular format, and that format has been displayed over this slide. So you can see here the RIP message format, it consisting of the version and the reserved and the family, tag, network address, subnet mask, next of address, and the distance. And this RIP, which is of two type messages we will be getting. In RIP implementation, we will be getting two types of messages, and the first message we call it as a request message, and the second message we call it as a response message. What do you mean by request message? A request message is nothing but it is sent by one router, okay, to another router. This request message, it is will be sent from one network and it will be transmitted to the another network in the case of timeout entries. In the case of timeout entries, so this request message will be sent, okay. And this request message, what are the information it will be holding? So it will be it will hold the information about the specific entries of all the neighboring nodes, or it will hold all the entries data in the request message. Whereas a response message, either it can be solicited or it can be unsolicited. So what you mean by solicited response is the message will be sent only to the corresponding request. In the case of sophisticated messages, the response will be sent only the message which has been requested. So for that only the message will be sent. And in that message, what are the information it will be holding? So it holds information about a destination specified. So what is the destination specified? It will hold. And what is the corresponding request message is there? So all those details will be held in a response information. And this RIP message implementation, as I told you, it is based upon the distance vector algorithm. So you can see here the distance from reaching one router to the another network, it has been highlighted in the distance table. So means what? In this distance, the distance of reaching from one network to the another network, or that is one router to the another network within the network, so that information will be available in the distance field. The next one we call it as a next of address. So the next of address, so as I told you, so one router will forward the data, that is autonomous system. One autonomous system will hold the address of the next autonomous system. So that autonomous system we call it as a next hop address. The next one is the subnet masking address. So this subnet masking address, it is used to do the prefix length. So based upon the prefix length, we can able to identify so what is the type of data that the information is need to be transmitted. So in order to have that, we will be appending this prefix length. The next one is the network address. So the network address is nothing but it is a destination address, and this destination address is nothing but a IP address of the network. And we have two important subfields. One we call it as a family, and one more we call it as a tag. So this family is nothing but it is a transmission protocol. It works upon the version 2. So we have two types of transmission protocol. One we call it as a TCP Tano and TCP Rano. So based upon the type of RIP message, so it may be response or it may be request. So based upon that, we are going to select the two versions of the TCP IP protocol, and that value will be corresponding to 2 in the case of family field. And the next one is version. So as I told you, this RIP protocol will works in the two important version. One we call it as RIP version 1, and one more we call it as RIP version 2. So the version field indicates so whether it is a current version or the previous version will be indicated. And the next one is the command. So this command line, it is nothing but either it consisting of a request message or it consisting of a response message. So in the command field you are giving 1 means, then it indicates that the RIP is a request message. If in the command field if it is 2 means, then we say that it is a response request. So you can see the RIP message, we call it as an entry repeatedly. We call it as an entry repeatedly. So if any one of the following information, either it may be family, subnet mask, half address, or it may be distances. So if any one of the family or any one of the entries will changes means, then it has to be updated in the RIP message format in this only. So this RIP message format we are going to use in the case of AS, that is autonomous system forwarding the packet within the network, and also the forwarding of the packet from one network to the another network. We will be using this RIP message format. And one more thing important information what you need to understand is, so in the case of implementation of your RIP protocol, whatever the implementation procedures we have adopted for the distance vector routing algorithm, the same we are going to use, but slight modifications. So what are the slight modification is that, so instead of sending only the destination vector that we were doing in the distance vector routing algorithm, so here what we are going to do is the router will send the information about the whole network entities. The router will send the information about the whole network entities in the form of response messages. So with the use of this response messages, the next autonomous system will come to know that what is the routing information and where exactly the data has to be forwarded to the destination network. Okay, and when a node or when an intermediate node receives a message or a packet, means then it will add the off count. It will add the off count. So let's say the router 1 has forwarded the packet to the router 2, means then the router 2 will add the off count as a 1. And since the data which was generated, or the data where the source is willing to transmit the data, so for that data transmission we will not call it as a half count 1. Why? Because since the data has to be forwarded from one network to the another network, so the source where the data has been generated, so for that corresponding source we will give a half count is equal to 0. When the source is transmit the data from one network to the another network, then we give a half count is equal to 1. And if the what happens if the receiver router does not have a information in the table, means then it will be added, it will be updated in the routing information. So if the destination what I want to forward the packet, if it is not available in my routing table, means then it will be updated based upon the response messages of your RIP protocols. So based upon the RIP response messages, the destination node where the data has to be forwarded or where the data has to be reached, so we will be adding in the by the use of the response messages. And if the cost of receiving the node, if it is less than the specified, means then the new route or the new path which has been established, so that path will be selected, whereas the previous path which has been identified, so that will be removed from the routing table, and the new path which is having the lowest cost, so that will be selected in forwarding the packet. So this RIP message, it is a 32-bit version. So you can see here the count value will holding a 0 to 8 bits, and from the version it is holding a 8-bit, that is nothing but A to 8. So you have got a 16, and the reserved field which holds a 16-bit address, that is a 16-bit data it holds. And one more thing you need to remember is that the network address is always we are going to specify the destination address. Why? Because we are not bothered about the source address, since the data is forwarded from one network to the another network. So we will not see which is the source node. We will only bother about the destination address, whether the destination address can be reached by the subsequent node or not. So that is why in the network addresses we are not mentioning the source address, we are mentioning only the destination address. And this RIP implementation, it uses three important timers for the implementation of the process for the operation. So the first we call it as a periodic timers. Okay, so these periodic timers we are going to use in order to control the advertising of the regular update messages. So we are going to use a periodic timers to control the advertising messages of the updated information we will be using. Okay, and each router what it does is, so at a particular one periodic timer, it randomly set one number, so that number will be between from 25 to 35 seconds, and based upon that it will be updated. So the timer will count down. So when the timer becomes 0, so the update message will be sent, and the timer once again it is set to a random value. And one more second timer what we are going to use is, there is a expiration timer. So this expiration timer, it is used to validate of the route. This expiration timer is used to validate the route. So means what, when a router receives the updated information, so that updated information will expire within 180 seconds. So if you're not possible for us you to transfer the data from source to destination within this 180 seconds means, then that timer, if it is elapsed means, then the path which has been established from source to destination, that will vanishes. And one more important timer, the last timer what we are going to use is, that is a garbage collection timer. By the use of this garbage collection timer, it is used to update the forwarding table. It is used to update the forwarding table. So in some cases what happens is, if the information which is available in the router, if it is invalid means, then what we are supposed to do is, the advertising message, so whatever we have used, so that advertising message matrix value we need to set it as a 16. At the same time what we do is, this garbage timer we will set it as 120 seconds. So when this counter reach to 0, then the routing table will be vanishes. So since it is an invalid routing table, so therefore we need to vanish the information which is there, or we need to delete the information which is there in the routing table. So we will going to use the deletion of the routing information once this garbage timer expires. So once we done the implementation, then we need to analyze the how best the performance of this RIP protocol. So the RIP protocol performances we are going to measure in terms of three important parameters. One we call it as update messages, and the second we call it as a convergence of the forwarding table, and the third one we call it as a robustness. So what do you mean by update messages is, so the update messages which are there in the RIP should be very simple format. So these RIP update messages are very simple format, and which will be sent for the neighboring nodes, and these neighboring nodes are local, and this normally they do not create a traffic when we are transmitting the messages in this RIP protocol. So therefore the update messages, whatever we are going to use in the RIP implementation, they are simple, and they incorporate, or they introduce a minimum traffic over the channel. The next one is convergence of the forwarding table. So since RIP uses a distance vector routing algorithm, so the convergence is very slowly in the data transmission. So as we have implemented this RIP protocol, the maximum number of hop count what this RIP protocol can produce is 15. So if it is more than 15 means, then the path or the data transmission will be abundant. The third one we call it as a robustness. So as this robustness, it is based upon whether the information is available, that is the routing information is available from one network to another network. Yes, in the RIP protocol, the information about the routing, forwarding the packet, it is available from one network to another network. So we can say that the robustness of the RIP protocol is more when you compare to the distance vector routing algorithm.